Hello, this is our first video for lesson 4, other triangle proofs. First thing that we are going to do is we are going to look at a special kind of proof for triangles called HL, and HL stands for hypotenuse leg. Hypotenuse leg. Okay. Based on the name of the proof, hypotenuse, well, it's special because it only works for right triangles. So let's take a look at that. And we're going to go to GeoGebra. So we'll go ahead and go there. And we don't need our axes, and we don't need a grid. So we'll just get rid of that if you want. First thing that I want to do is I'm going to just create a right triangle, and this is a little harder than it seems. We're not going to just use a random triangle. We're going to build it using segments. So I'm going to build one of the legs of my triangle here, okay, the bottom leg of my triangle. Now, to ensure that I get a right angle on my triangle, I'm going to go over here, and I'm going to use the perpendicular line. And to do that, I'm going to click on this point, and then I'm going to click on this segment, and that's going to draw a perpendicular line. Okay. We're going to get rid of the, we're going to hide this later, but this will allow us to put our third point of our triangle. We want that third point to be on this line, so we go over to our point menu, and we go to the second one down, which is point on object. So I'll click on that, click anywhere on this line. I can move that point later on. So you can see I can grab this and move it. Oops. I can grab this point here and I can move it up and down on this line, but it won't move off that line. So I keep that right angle. Okay, I don't need this line anymore. I don't want to delete it, so I'm just going to hide it. I'm going to go back to my segments and connect the remaining two sides, and now I have a right triangle. Okay? And oops, and I can move it, okay, reshape it, but it's always going to stay a right triangle. So what we're going to do is we're going to make a copy of this right triangle, but only by copying just one of our legs and the hypotenuse length. Okay, and just to illustrate that, I'm going to change that color of that leg to red. Okay, and I'm going to change this to a green. You don't have to change the color, but I'm just going to do that just to illustrate which legs we're copying. Alright, let's go ahead and copy this segment. To do that, we go to a segment of given length. I'm going to put it over here. I'm going to place a point. It's going to ask me how long do I want it. I want it to be the same as this segment, so I'm going to call it F, or whatever your GeoGebra called this segment. Okay. And so now you'll see, I'm going to change this guy to a red as well so it matches. But you can see that if I make the leg longer, this one matches it. Okay. Alright, now I want to copy this segment. Okay. Now in order to do that, I'm not going to use a segment of given length. I want to copy a length by using basically an arc, like as if we had a compass here. And to do that, we're going to use a circle of a center and radius. I'm going to click on that. I'm going to click on E as my center. It's going to ask me how big I want my radius. Well, I want it this length here. So in my case, it's labeled I. You label it whatever your GeoGebra labels it as. Okay? And so now I've got a circle, and this would be if I had this this leg like wasn't attached to anything, it would be spinning around in this circle here. Okay. Alright, now I need to make the right angle. So I'm going to go to a perpendicular line, and just like we did here, I click on this guy, and this guy. So now I've got this right angle here. And if I were to connect a segment to that point, I would match this original right triangle. So to do that, I'm going to go ahead and go to intersect. Intersect that circle with that perpendicular line, and I'm going to connect change that. That's going to be a green segment so it matches. Connect those two, and I'm going to go ahead and make sure I connect D to E. We'll make that purple. We'll match that with this one. We'll change this one to purple as well so we can see the different segments. Yeah. Okay, so by copying the red leg and the two green hypotenuses, did we end up with an exact copy? Well, let's change the original triangle and see if it matches. And yes, it matches. Okay, so we're going to go ahead and copy this. We'll go to a Word document, do a screen capture. And there we go. I'm going to click on this guy so I can move it around. I'll shrink that up a bit so we can make sure that we can paste that onto our notes. Okay, and that is our HL, proof of congruence. Well, how about an example of a problem using HL? Here's two triangles. They've already marked that BD and FD are congruent. Okay? They've already marked that those two are right angles, meaning that we could use HL if we wanted. And then they give us that D is the midpoint of CE, which means that those two sides. So, do we have a hypotenuse and a leg congruent? Yes, we have a hypotenuse congruent and a leg congruent on this triangle. We have a hypotenuse congruent to a leg congruent. So therefore, by HL, those two triangles are congruent. Okay. All right. I'd like you to work on question number 3 and question number 4 before we move on to the next video.